Okay, this is the last tutorial. Just what I wanted to show you here is another way of working with this brain data. One of the things I've been mentioning is the grain stretch, which allows you to um, take a sound and stretch it into these very, very long moments without affecting its pitch. So I wanted to show you that. We looked at this about midway through the semester, but I don't think I made a video for that, and I wanted to kind of just show you how you could put it all together in a different way. So we're just taking the new outlier kind of removed mapping here. I'm just sending it from 0 to 1. I'm going to send it to our grain patch, which I'll show you in a second. So basically I've changed this to say every second read through a different number of Abigail's brain activity. This is the one that we're sending right now. Okay, so I'm just going to hide that because we're not going to really use that so much. I'm going to go over here. I've put this on eCampus for you. One of the ways that we work with audio in Max is to put sounds into a buffer. A buffer is an amount of RAM allocation, memory allocation on your computer. This one, I've just called it hum. You could call it anything that you want to. See how, but they all have to be shared. This is the main object we're going to work with, this grain stretch tilde one. You will all have that, but notice that it shares this argument hum, hum, hum. Okay, so that's saying allocate two seconds of space in the RAM of the computer for this. And so here's my mic. You can see my voice. Okay, so you can't get any more boring than that. So what I'm going to do is let's just listen to that, and I have this. Okay, so that hit there, that's just my turning on this key thing here. So I just wanted to show you with this, what this allows you to do is, I'm just going to lower you, you could lower that speed to 10 times lower. So I thought there was something about like the human like mantra voice. You could even go 20 times slower. And let's bring this grain size down. Okay, so this is a 20 millisecond grain. Okay, going very slow. You can also, of course, bring that to like half speed and bring the speed to 1 but the pitch down if you wanted to do that. It's hours of fun for the whole family. Okay, so I wanted to show you that. Now, in addition to this, you can send this audio over to, let's just take our super slowed down pitch one, speed one. When you do this like that, you're making what they call a cloud. Let's take this cloud and send it over to our filter. Here. And send that in there. And I also want to, I don't want to hear this sound anymore, so I'm going to just hear this filtered one. And what we can do here is let's just listen to the dry one. What I have going on is I'm taking that same beta wave data. It's mapped from 0 to 1. I'm just putting it in a range of frequencies, 20 hertz low frequency to like a kind of higher frequency. And we can change that. Maybe I've gone too far. We're missing some of it as it goes higher up. Maybe 3000 is a better. And what we're doing here is this is just a beat straight from that. Every second we're using that. You don't even need to have this. You could have it be endlessly playing. That's fine too. Let's just hear what that would sound like. So you don't need this. I just wanted, it's the thing that is kind of supplying the beat if you want it that way. Let's bring in our delays here. Okay, this one's longer than this one, and these will change based on your. So now what we're doing is we're super slow-mowing the hum, and we're using the brainwaves to kind of shape our mantra in a way, this kind of like sound. And so that's a kind of a cool thing. Now you could keep going, so I'm just going to keep playing a little bit and show you some other stuff. Last thing here, you can also take this here, and you could have it, this is the thing that goes from 0 to 1. We could use that to control the pitch. Now let's bring back just this one, and so we can hear what that's like without all the effects. So what I'm doing here is I'm taking this 0 to 1, and these are connected, they're just hidden right now. And this is just saying take whatever comes in, make it go to this new one, and make it go from the old one to the new one. You can play with that to figure it out, but let's make this be 1000. Okay, so the pitch is responding to the brainwave data now, and it's controlling the sound of the hum at this cloud-based level. We could change the speed to... I like it slower though. You could even have this control the speed if you wanted to see what that's like. And then let's say bring this to 1. Okay. One last thing here. I kind of liked it better controlling the pitch. Here's a different approach you could take. You could, instead of having it go to the pitch here, you could set the grain size, which might be a more subtle effect. Typically, as you know from your granular synthesis PowerPoint section of the key terms, 10 to 150 milliseconds might be good ranges here, and now we can throw that in and see what that sounds like. And let's just put the pitch up. So this is like a little bit more subtle effect. Of course, you could duplicate this and send both going, and there you go. So those are some fun things. You could bring back in the other effects and all that. But I wanted to give you a sense of how to use this grain stretch, how to use the buffer. One last thing here. If you like anything that you're doing, you can just use this SF record and then say, I'm going to put this on the desktop and say today's music. Okay, that's probably a terrible title. Okay, there we go. You just hit that to start, hit that to stop, and that you've just recorded what we've just done. Okay, so I'm going to save that, send it to you, and some fun stuff for the whole family. Bye.